So in this problem, we're given this two inequalities, and we're asked to find which of the following cannot be the value of r. So one way to do this problem is to select values for different values for r, and then see if we violate any condition for s. So for example, if I set r to be 0, this is going to become 0 is less than or equal to 4s plus 5, which means 4s is greater than or equal to minus 5, s is minus greater than or equal to minus 5/4. They're telling us absolute value of s is less than or equal to 5, which means if we choose, for example, s to be 0, that's going to satisfy both of these. So 0 is a possibility. We need to find one that is not possible. So let me try 5 for r. So that would be, so here the process is a little bit random in terms of how I'm going about it. So here for s is greater than or equal to 10, or s is greater than or equal to 2, that again I can pick s equal to 3. That would satisfy both of these, so that one is out. So here I'm actually going to go to a higher value for r, because I know that that's going to increase the constraint on s. You'll see this. So that means 4s is greater than or equal to 55. S is greater than or equal to 55 over 4, which is 4 times 3 is 12, 13 and 3/4. But our condition is absolute value of s has to be less than or equal to 5. So there's no common value here that would satisfy this, which means r cannot be equal to 20, and that's the answer, which is choice E. The other approach that I thought when I saw this problem is perhaps graphing. I'm not sure if that would be more efficient, but that's kind of the decisions you have to make in the exam. You don't know which approach would work. I just thought using the examples was the easier approach here. So we have to make a graph of this inequality. The first one is s is less than or equal to 5, which means s would be between minus 5 and 5. So that's this inequality, and that one, the equation would be 3r equal to 4s plus 5, and the y coordinate is 5/3 when s is 0. So if this is 1, this is 2, so that would be somewhere here. So 0, 5/3, and the x coordinate would be when r is 0, so s would be minus 5/4, so that would be minus 1, so it would be somewhere here. So that line would look something like this, and if we use 0, 0 origin as a test point, is 0 less than or equal to 0 plus 5? Yes, which means that does fall on the side where this inequality is, so that would be this region. So that's the common region here. So any value of r that's outside this wouldn't satisfy. So if I look at the values minus 20, minus 5, 0, 5, and 20 are equal to 0 works. 5 are equal to 5. So depending on, I think if we choose the value, an appropriate value of s, it would fall somewhere here. So that one is out. Minus 5 again, sort of here. If I choose something for r, minus 5 would also be here. So that one is out. Minus 20 again down here, and we're left with 20, which would be way out there, and that's going to go beyond that. So it's actually not very obvious here. So this is probably not the best approach to use for this problem, but in some other cases you might be forced to use this approach. So just using the examples and finding the constraint on these two inequalities was the best approach. So this is something you have to deal with in the exam, which approach to take. You have to make a shot. And in this case, the original approach that I chose was the appropriate one. So to summarize, the answer is E.